What we're doing today is not going to require any calculations. We're going to be interpreting graphs. We're going to look at a graph, and you're going to use your calculator to graph it. And then we're going to have to answer questions about the graph. We've already done some of it where you look at a graph and you tell the domain and range, right? Domain is how far left and right does it go. Range is your y, so how far up and down does it go, right? Okay? We can look at a graph and tell what the maximum or the minimum point is. For example, in this quadratic, is this a max or a min? That's a minimum, right? In a linear equation, there's no max or min because there's no highest point or lowest point. Okay, so if you're given a graph, it might say, tell me the maximum or the minimum. The first thing we're going to talk about are parent functions. Parent functions are the stripped down function, the stripped down version of the function, meaning it's not shifted at all. It's not mathematically changed. It is plain bare function. That's called the parent function. H and K are the numbers we saw with parabolas. H and K in a parabola is our vertex. H and K moves that vertex from its original starting point. Its parent function for a quadratic, the vertex is at 0, 0. Because H and K are 0, 0. So if you change those values for H and K, it shifts that function, left, right, up, down. Okay? And we're going to talk about those shifts in a minute. So in all of the parent functions, H and K are always 0. Now, you're not going to have to sit there and memorize all of these forms, all of these standard forms. You're not going to have to memorize that. We're going to do several examples where we're going to look at equations. You're going to tell me what H is, what K is, and it's going to become easy for you to pick out. Okay? But I just put all the original forms so you can see if it's a parent function, H and K are just 0. It's the stripped down version. So in a linear equation, the parent function is just y equals x. It's just y equals x. It's a diagonal line that goes through the origin. Okay? You good? In a quadratic, it's just y equals x squared. It's just y equals x squared. It's a regular parabola that opens up and the vertex is at the origin. That's the parent function. Square root is y equals the square root of x. Now I want to talk a little bit about y equals x squared, its graph, compared to y equals the square root of x and its graph. X squared and the square root are inverses of each other, right? Okay. So you would think that on a graph, the graphs would look the same. It would just be sideways. Right? But when you compare a quadratic, which is y equals x squared, to a square root, which is the square root of x, we're missing half the graph. Like if I took this graph, this quadratic, and turned it like this, you would think it would look like that, but it doesn't. It doesn't. Why not? Yes. Very good. Because you can't have a negative. You can't have the square root of a negative number. You can't have a square root of a negative number. So it's missing the other piece because square root has to be positive. Does that make sense? Technically, they would be the same graph, but they're not. Because you can't have the negatives. Okay? So I just wanted to let you visually see square root compared to x squared. You're just missing half the graph because you can't have square root of a negative number. But with square root, that starting point is still at 0, 0. Okay? It's still at 0, 0. And the reason why I'm saying this is because if you're given two graphs of two square roots and I ask you what happened from the original to the new, and you don't have the equations, you're going to look at those starting points and that's what you're going to compare to see how did it get shifted. If it went from here and ended up here, that means it went up 2 units. Okay, that starting point went up 2 units. All right, so those starting points are good visual indicators of what happens to the graph when you don't have the equation to look at. All right, let's look at the rest of our functions. You don't have to memorize these. Listen, you have your calculators on you. So if you ever forget, what does the absolute value of x graph look like? You go in your calculator and you put in the absolute value of x. And just to refresh your memory, absolute value can be found at the math menu on your calculator. It says ABS. Okay, let's talk about a cubic. A cubic is y equals x cubed, right? Let's compare that graph to y equals x squared. Because I want y'all to logically make sense of why these graphs look the way they look. So y equals x squared, that's right here, right? Okay, anytime you square something, the answer is what? Positive, right? So if x is 1, it's positive 1. If x is 5, it's positive 5. If x is 10, it's positive 10. But if x is negative 1, it's positive 1. Y is positive 1, right? So that's the reason why it goes up in both directions. Cube, is that the same case? No. If x is positive, y is always positive, right? But if x is negative, y is always negative. So they're similar. A square root does like this. Because when your negative values, the y is positive. But if it's cubed, then it's negative. So that's the reason why it goes up like this and then down like this. So that's why a cubic is shaped like that. Okay? I didn't put a cube root, but a cube root is the inverse, right? Cube root is the inverse of cubes, right? So it looks like this graph, just turned sideways. Okay, so that's what cube root looks like. Same shape, just turned sideways. Absolute value looks like a Y or a V. Okay? Absolute value of any number is always what? Positive. The absolute value is always positive, right? Okay, if this was just y equals x, it would be a diagonal line, right? But if it's the absolute value of x, when you get to these negative values, they're also positive. So it's similar to, say, x squared, right? But absolute value of x is just, they're linear, but they both go positive. Does that make sense? Okay. And also, we need to mention, a cubic starting point is at 0, 0. It's at the origin. Okay? And absolute value starting point is also at the origin at 0, 0. And it's a minimum. Absolute value has a vertex. Okay? It's a minimum. Now, logs and exponents, we did this. We just did this in the last section before this. What's different about logs and exponents for their parent graphs is the bases change. The base can be anything in the parent graph. All right? So an example would be log base 2 of x. That is an example of a parent graph. Another parent graph of a logarithm would be log base 5 of x. Log base 10 of x. ln, which is log base what? E of x. Those are all parent graphs. Your bases can change from parent graph to parent graph. And same thing with exponentials. The base can change with the parent graph. That's a times log base b of x minus h plus k. Oh, its starting point is at 1, 0. Its starting point is at 1, 0. All right? And for exponentials, which is the inverse of a log, right? Its starting point is at 0, 1. If you take a logarithm graph and turn it like this, you have an exponential graph. So if I gave you a big complicated function, 1/2 times log base 2 of x minus 3 parentheses plus 5, and I say, what's the parent graph? It's log base 2 of x. You see log, it's just log whatever the base is of x. Okay? You strip it all down, but you leave your base the same. Okay? Okay. Now we're going to look at some graphs. This is where I said just roughly sketch this graph. You don't need to put square root and all this. Just draw the graph. And we're going to talk about end behavior. How many of you heard of end behavior before? Anybody? No? Okay. End behavior is what's happening to the function as x approaches infinity and negative infinity. F of x is the same thing as y, okay? End behavior is not difficult, but it's easy to get tongue-tied with all the terminology. This arrow, we read that as approaches, okay? So, what this means is, as x is getting bigger, what's y doing? And as x is getting smaller, what is y doing? And you can look at your actual graph to easily tell that. Do y'all have the top part?
No.
No. I would draw a quick graph of the square root and a quick graph of the cube root. Too far?
Yeah.
Okay, so this reads, if I'm reading this, it says f of x approaches what as x approaches infinity. As x approaches infinity, that means as x gets bigger, here's x, right? As x gets bigger, what is our function doing? Our function is getting higher, right? Those y values are increasing. As x gets larger, this is getting bigger. So this is what I do. When I have to do end behavior, I look at the ends, both ends of my graph. This is the right end of my graph. It's getting larger and larger forever, right? So it's approaching infinity. Okay? Now remember, we're talking about what's happening to the y values. Okay? What's happening to our function. Okay? We look at the other end of the graph, which is right here. Where is that on the y-axis? 0. So, as x gets larger, that means I'm reading it to the right, my y value is getting larger also, right? So it approaches infinity. And as x gets smaller, as x approaches negative infinity, my function approaches 0. This is the same thing as y, right? F of x is y. Y goes to infinity as x goes to infinity. As x goes to infinity, y goes to infinity. Because where does y go? Where does my function go as x gets smaller? How far does it go on the y-axis? It goes to 0. It stops. End behavior is sort of another way to talk about the range. If I said, what's the range of this? How far high and low does it go? You would tell me it goes from 0 to positive infinity, right? The lowest point is 0, and the highest point is positive infinity. That's the range. Okay? So in behavior is tied to the range, if that might help you to understand it better. If you're telling what's happening to y as x gets bigger and smaller. Okay? Before we talk about increasing and decreasing, let's do this one. Okay? First thing I do is they say, what's the end behavior? I'm going to go draw my little pictures on both ends. Okay? Now, as it goes to the left, what's happening? It's decreasing, it's going down, right? My y values, as my x values get smaller, so do my y values. They get smaller and smaller and smaller, right? If I looked at a table and I looked as x got smaller, y would also get smaller. So this goes to negative infinity. And what about this side? Positive infinity. Okay? As my x values get bigger, my y values are also getting bigger. Okay? These tell what's happening to the y values as you head in those directions. Okay? So, read this. Read it out loud. Good. And then good. It seems complicated, but once you get the concept, it's not. Okay? It's just you're describing what's happening to y. Okay? Increasing and decreasing. This is another way, basically, that they ask about the domain. You're telling what intervals, if any, what intervals of x is y increasing or decreasing. Okay? So, you can easily look at the graph and see increasing or decreasing. Now, like I said, this is like your domain. This is as you're going from left to right. An interval is from a certain value of x to a certain value of x. Right? If I ask you, what is my domain of this? X is greater than 0, right? That's my domain. Now if I asked you, what interval of x is that graph increasing? Where does it start? At 0. And where does it go to? Infinity. So the interval is from 0 to infinity. That's the interval that it's increasing. Is it ever decreasing? No. Because you're just going from left to right. It's never decreasing. Because you could have some crazy looking graphs. They might give you some crazy looking graph that'll be like, it'll be like, and say, this lines up with -3, this lines up with +1. So, it's increasing from negative infinity to -3. Y'all see that? And it's also increasing from 1 to infinity. Do you see that? But it's decreasing from -3 to +1. Do y'all see that? So that's how, when they're talking about increasing and decreasing, it's an interval for which that graph is increasing or decreasing. Sometimes it's only one, sometimes it's both. And so for the second one, as I go from left to right, what does it do the whole time? It increases the whole time, right? I come right here, getting bigger, 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 bigger. It keeps going, right? It's increasing the entire way. So it's increasing from negative infinity to positive infinity, and it's never decreasing. So, on the final exam, they'll have some crazy looking graph like that, and they'll say, for what intervals is that increasing? And you'll have to choose those intervals, okay? And this one would say, the answer would be from negative infinity to negative 3 in union with 1 to positive infinity. That would be the answer. Because it's those two intervals that it's increasing. Here and here. Right? Okay. Let's look at one more example of this, and then we're going to talk about how things get shifted. So y'all try these two. Answer those questions for those two. Okay, if I put my little pictures on the ends, what goes up here?
Infinity.
Positive infinity. What goes down here? All right. So f of x approaches what as x approaches positive infinity? Positive infinity. F of x approaches what as x approaches negative infinity? For what values of x is that function increasing? It's increasing the entire way. From negative infinity all the way to positive infinity. Remember, increasing and decreasing, you just go from left to right. So it's increasing from negative infinity to positive infinity. Can't say 0 to positive infinity because it's also increasing on this side too. It's increasing the whole way. Is it ever decreasing? No. Okay, let me put my pictures. What goes on the left-hand side?
Negative. No, positive.
Positive. That's going up. My y values are going up. What goes here? Positive. My y values are always going up. Right? So f of x approaches positive infinity as x gets larger, and y approaches positive infinity as x gets smaller. It's going up in both directions. Okay? Increasing and decreasing. What values of x is that function increasing? 0 to positive infinity. It's increasing on this side. So from 0 to positive infinity. What values of x is it decreasing? From negative infinity to 0. Values of x. Values of x. We're talking about these intervals here. Values of x from negative infinity to 0. Increasing and decreasing. Values of x. The last thing we're going to, are y'all done with this? The last thing we're going to talk about is how things are shifted. Now, we've been talking about this a little bit, h and k, and how they affect an equation, how they affect the function, okay? They shift that function left to right or up and down. H represents your horizontal shift along the x-axis. Your x-axis goes left and right. H is your horizontal shift. H is going to be always a value that's either added or subtracted to your x. And that makes sense because it manipulates it along the x-axis. Okay? K is your vertical shift along the y-axis. That either moves, starting at the parent function, it either moves it up or down. Based on that number that's added or subtracted. That's associated with your y value. Okay? A is the number that's multiplied to your function. With our parabolas, A was that number that was multiplied to that x squared term, right? Or y squared term. We looked at A to determine whether that parabola opened up or down, right? If A was positive, it opened up. If A was negative, it opened down. The reason why is because if A is negative, that means it's reflected across the x-axis. So that's how come it took a regular parabola and it flipped it down. That's why it opened down. Okay? Now, we're going to talk about how these things shift based on the value of h and k. I'm not going to pay attention to the number that A is. All I'm going to pay attention to is whether it's positive or negative. You're going to look at that and you're going to tell me whether it's reflected or not. If A is negative, then it represents a reflection. If A is positive, it's not reflected. That's all you're doing in terms of A. When you get to pre-cal, you'll learn some things about how that value changes that graph. It's either going to shrink it or stretch it. Okay, but we're not doing that. All we're doing is tell whether it's a reflection or not. So for each one of these functions, we're going to pick out what h is, what k is, and what a is. And then we're going to describe what that did to the original function. Now, when I'm looking at this first one, y equals negative absolute value of blah, 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 blah. I want you to tell me what's the parent function of that. What's the stripped down version? Absolute value of x. That's the stripped down parent version. Y equals absolute value of x. If I took everything else off, that's what will be left. That's my parent function. This, we can call it the child function. It's the kid. Where did it go? And that's what we need to figure out. When it left the mama, where did it go? Okay? When we're looking at this, what is h? It's positive 2, remember? Because all of those forms, it's x minus h. So just like when we picked out the center and the vertex, it's always the opposite, right? So h is positive 2. Huh?
Yes.
Oh, I thought you were talking. Okay, so h represents your horizontal shift. If it's positive, that means it took it from here and shifted it 2 units to the right. So this means 2 units to the right. Okay? The absolute value, that starting point is at 0, 0. So for this one, that shifted it 2 units to the right. That moves you over to 2, 0. You understand? Okay, what's K? 4. That's your vertical shift. That moved it 4 units where? Up. That moved it 4 units up. So we went 2 units to the right and 4 units up. Okay? What's A? Negative 1. Okay? I don't really care what the number is. I just care that it's negative. Absolute value started off like this. Once it's reflected, it did this. So it shifted it 2 units to the right, 4 units up, and then reflected it. Okay? That's what you have to be able to look at these graphs. Like I said, we're just interpreting. And I say, tell me, explain the transformations. You would say 2 units to the right, 4 units up, and reflect. All right? Now, for this next one, what's H? That means it got shifted where? 1 to the right. What's K? 0. So it didn't go up or down at all. And what's A? 1. So is it reflected? No. Okay. I'll give you your worksheet. I know the bell's about to ring. But here's our function. F of x equals x squared. We have to write a new function with it shifted left 2 units and up 5. If I have to shift it left 2 units, x plus 2 That means it got shifted left 2 units,
Oh.
right? And up 5 plus 5. Okay? Last one.
Wait.
Sorry. Okay, last one. Here's your function. Granted, it's not a parent function, but it's okay. Take g of x and shift it left 5 units and down 2. This is how it'll be asked on the final exam. You'll have to pick out the new function where it started here. Where does it end up? If I'm shifting it left 5 units, X, right. If I'm shifting it left 5 units, I have to add 5. Because it's the opposite of what's in here. Right? So that would be, you have to add 5, so you end up with x minus 2 squared. And if I'm shifting it down 2 units, what happens to this? You subtract 2, right? So that's just plus 2.